This video clip is part of the EPFL introductory course on information computing and communication. It is the first one in a set of video clips on memory hierarchies and management. It introduces the topic and then briefly reviews typical memory and storage technologies. Whatever we do and wherever we look, it is obvious that we are immersed in an increasingly digital universe. Not only science and engineering, but also commercial business, entertainment, and everything else swims, even drowns in digital data. In 2013, the total amount of digital data worldwide was estimated at around 5 zettabytes, where a zettabyte is 10 to the power of 21 bytes. Where and how can that much data be stored in a way that we can manage to find and retrieve it when we need it? To start answering this question, let us first review what memory and storage technologies are available to store digital information. On this slide, one can see a range of technologies, including so-called cache memory found inside a processor chip, main memory or primary memory found inside computers but off the processor chip, flash memory found in USB sticks or tablets, solid-state devices, SSDs as they're called, hard disks, disk arrays, and magnetic tapes. Let us look in some more details at the properties of and differences between these technologies. All such memory and storage technologies are characterized by three main properties: their capacity, their performance, and their retention ability. Their capacity is in turn characterized by how many bytes, more often kilobytes or today gigabytes, a typical device of that technology can contain, and what the unit cost of that technology is per gigabyte. Their performance is characterized by their latency and their throughput, where the latency is the time needed to access a given byte on a device, and the throughput is the number of bytes that can then be transferred in or out of the device every second. Their retention characteristic specifies whether they are able to retain information when powered off, or whether this information is volatile and erased, lost, when powered off. This slide shows the capacity that is typical of a number of storage technologies, as well as what capacity is needed to store logical units of information such as text, images, audio, or video information. So for instance, one can see that a typical book, a high-definition picture, or an MP3 clip requires roughly 1 megabyte of space or so, whereas about 1 hour of music or video will fit on a CD or a DVD respectively. Today's high-end discs can, however, store a whole library of hundreds of hours of movies. This next slide shows the evolution of device capacity and latency for some of the key storage technologies: hard disks, flash, and main memory. As one can see, hard disks typically offer a much higher capacity, but also a longer latency than main memory. One can also see on the latency graph that today's processors have become much faster than main memory, requiring or producing information much faster than main memory can provide or take it. These are key observations to understand the video clips of this lesson. Flash memory lands on these graphics somewhere in between hard disks and main memory. The last slide in this video clip summarizes the latency, throughput, unit cost, capacity, and retention properties of the main memory and storage technologies. As can be seen, main memory technology, also called RAM for random access memory, is much more expensive than other technologies and provides substantially less capacity per typical device. This is another key observation for understanding the further video clips of this lesson.